Alrighty, in this video we are going to be talking about how to solve logarithmic and exponential equations. So there are going to be two types of solving logs, the two types of solving exponential equations. For the first type, it's going to be very, very easy. It's going to be logs on every term. And if we have logs on every term, we're going to be happy. But before we do that, we want to have one log on the left side and one log on the right side. So if that's the case, then we could just drop the logs and only look at the arguments. So for example here, if I have log base 5 of x and log base 5 of 3, since I have the same bases, I can just drop them and say x is equal to 3 and call it a day. Same thing for example 2, if I have log base 6 of x plus 2 and log base 6 of 3, I can drop the logs and have x plus 2 is equal to 3, and x is equal to 1. Now, if I have two logs on the left in this case, and then one log on the right, I want to condense it so that I only have one log on the left and one log on the right. So always one log on the left, one log on the right. So thinking about our properties of logs, remember that we're going to not subtract since this is addition. Since this is addition, we are going to go ahead and condense this by multiplying the arguments together. So after we have one log, we are going to go ahead and drop the logs and only focus on the argument. Then let's go ahead and simplify this. So that's going to be x squared plus x minus 6 is equal to 14. I'm going to go ahead and solve for 0, or set this equal to 0, not solve. Then I'm going to factor. Then I'm going to set both factor equal to 0. So we get x is equal to -5, and then x is equal to 4. Now, one thing that I haven't done in examples 1 and 2 because they were easy peasy lemon squeezy is because for number 3, we have a quadratic. And since we have a quadratic right here, we do want to check for extraneous solutions. Now remember that the domain of a logarithm goes from 0 to infinity. So if I were to think about my argument here and I plug in, let's say -5, notice how if I plug in -5, I'm going to get -5 minus 2 or -7. So this is saying log base 7 of -7. The problem is I can't have a negative argument right here. So this is going to tell me that -5 is an extraneous solution. We don't like her. We don't want her. Now if I plug in 4, I'm going to have log base 7 of 4 minus 2 or log base 7 of 2 plus log base 7 of 4 plus 3 or 7. And if I were to condense them, I'm going to multiply 2 and 7, and that's going to give me log base 7 of 14, which is what we want. So our final answer here is x is equal to 4. All right. For type 2, terms with and without a log, we are going to change to an exponential. But first, like I said, we always want one log somewhere, whether it's on the left side or the right side. In this part, it's probably going to be on the left side. Now remember, to change this to an exponential, we are going to have my logarithmic base be my exponential base. So this is going to be 2. My answer is going to be my power, so this is going to be 2 to the 5th is equal to 5x plus 7. So then we have 32 is equal to 5x plus 7. 25 is equal to 5x. X is equal to 5. Same thing for example 2. The problem with example 2 now is I have to make sure that my log is isolated. So before I convert this, I'm going to go ahead and divide by 2 so that I have ln of 4x minus 1 is equal to 3. Now remember that ln is the same thing as log base e. So now I could say log base e of the 4x minus 1 is equal to 3. I'm going to e both sides or convert this so that I have e to the 3rd is equal to 4x minus 1. I'm solving for x, so I'm going to have e to the 3rd plus 1 is equal to 4x. Then I'm going to divide by 4, which gives me e to the third plus 1 over 4. All right, so with example 3 here, we are going to go ahead and once again condense the left side of the equation, just because I have 2 logs and I don't like that. I only want 1 log on the left. So condensing this, I'm going to have log base 4 of x times x minus 12, which is going to be log base 4 x squared minus 12x is equal to 3. Once I do that, I'm going to go ahead and convert this into an exponential. So now I have 4 to the third is equal to x squared minus 12x. And then we know that 4 to the third is 64. So now I have 64 is equal to x squared minus 12x minus 64. And then, oops, make sure that this is 0 now. And then I'm going to factor this. So now we just need to think about factors of 64. That is going to give me a sum of 12. And that's going to be 16 and 4. Set that equal to 0. Set each factor equal to 0. So you have x is equal to 16 and x is equal to negative 4. Now, once again, because you have a quadratic that we had earlier right here, you want to check for extraneous solutions. So unlike number 2 and number 1, I didn't check for extraneous solutions just because I didn't have a quadratic with me. So always check if you have a quadratic or you built a quadratic in the middle of your steps. So now we are going to check for 16. So if I plug in 16 here, log base 4 of 16 is 2. And then here, if I check for 16, and then 16 minus 12 is 4. Log base 4 of 4 is 1. So 2 plus 1 is 3. So we know that 16 works. Now, if I check for negative 4, I have a problem because then I'm going to have log base 4 of negative 4, which is not good. So we know that negative 4 is an extraneous solution. All right, same thing for number 4 here. If I have log base 4 of 2x plus 1 and log base 4 of x plus 2 and log base 4 of 3, I could do a couple of things. The first thing is probably condensing the right side. Now, because this is a subtraction problem, I'm going to go ahead and divide my arguments. And then at this point, because I divided my argument, I have 2x plus 1 on the left side as an argument, and then x plus 2 over 3 on the right side as an argument. Because I have a log on the left and a log on the right, I'm going to go ahead and drop the logs and have 2x plus 1 is equal to x plus 2 over 3. Then I'm going to go ahead and solve that. So then I have 3, 2x plus 1 is equal to x plus 2. 6x plus 3 is equal to x plus 2. Subtract x, so that's going to be 5x. Then subtract 3, that's going to be negative 1. So x is going to be equal to negative 1/5. Now, even though we have a negative answer here, you are going to be fine, because if I were to plug in, let's say negative 1/5 here and negative 1/5 here, we're going to see that this is going to be positive, the argument, and this is going to be positive, the argument. Because my arguments are positive and not negative, we're good. Even though we have a negative answer, that's fine. All right. For exponential equations, we have 2 types. I'm going to focus on the second type first because I think that's easier and that there's only one question. We're going to rewrite them so that the bases are the same. So in this case, this is just me saying if I have 2 to the x is equal to the 4 to the 2x plus 1, then think about what my base could be so that 2 and 4 could be the same base, or in this case, base 2. So now I have 2 to the x is equal to 2 to the 4x plus 2. X is equal to 4x plus 2. Subtract 4x. Negative 3x is equal to 2. X is equal to negative 2/3. Now, once again, you do not need to check for extraneous solutions because we did not end up with a quadratic anywhere. So we're good here. All right. Bases are different. We are going to turn them into a log. So we are having example 1 here and example 2. I'm going to do example 2 because example 1 is going to be a little bit harder. Now remember that for example 2, if I have a e as a base, well, because I have e as a base, and this is an exponential problem, I'm going to convert this into a log. So if I convert this into a log, remember that's going to be log base e, and then I'm going to have 19 is equal to 4b. That way, whenever we convert this into an exponential, I'm going to have e to the 4b is equal to 19. Now I've got to solve for b, so I'm just going to divide by 4 and call it a day. Now, on the test, you will be expected to maybe convert this into the common log. And remember that the common log is base 10. So if I were to convert this into a common log, this would be equivalent to log of 19 over log of e times 1/4 is equal to b. All right, and then for the last one, this example right here, I don't think it will be tested. Maybe not. But this one is a more difficult problem because you have 2 bases that are different. But essentially, we're using the same strategy that we did with number 2, where we're converting this into a log. The problem is whether you convert 7 to a log or 5 as a log, doesn't really matter. But since this one's first, I'm just going to convert this into the log. So that means I'm going to have a base of 7. But then I'm going to have 5 to the m as my argument. And then I'm going to have m plus 4 as my answer. Now, once we do that, you'll notice that we have an m right here and an m right here. That's okay. Because remember, one of the properties that we've learned is that we could take out the exponent of m and put it as a coefficient and multiply it. So now this is saying m log base 7 of 5 is equal to m plus 4. You are going to subtract m because we want the m's to be on one side. Then we're going to factor out an m, because we only want one m now. And then we are going to divide by log base 7 of 5 minus 1. And this right here is my final answer. Now, even though there weren't a lot of steps to it, you just have to figure out that if we have 2 of this different bases, we're going to convert this into a logarithm, and then you got to use your properties. In red, I'm going to do the same thing, but now what I'm going to do is have 5 as my argument now, not argument, base. So now I'm going to have log base 5 of 7 to the m plus 4 is equal to m. Now, like we did earlier here, we converted this exponent and we put it up front as a coefficient. So that's what I'm going to do with this m plus 4. so that I get this thing right here. Now notice how this m plus 4 is in parentheses. So what I'm going to do now is go ahead and multiply the m plus 4 with the log base 5 of 7. So now I have m times log base 5 of 7 plus 4 log base 5 of 7 is equal to m. I want m's to be on one side, so I'm going to move the m log base 5 of 7 to the right side. Factor out an m like we did earlier. And then divide. Now, you'll notice that this one took a lot more in terms of our steps. And that was because notice how here our exponent was m, and here our exponent was m plus 4, and we needed to move the m plus 4 up front, which means that we had to multiply out with the m and the 4, which kind of took a bit. You'll also notice that my answers are kind of different. So I have 4 log base 5 of 7 over 1 minus log base 5 of 7. However, I promise you, you'll be fine that these two answers are equivalent to each other. So if you want to put this on Desmos and verify that they're equivalent to each other, you could do that. So that you can see that, oh, they're actually the same. All right, so that is it in terms of solving exponential equations and logarithmic equations. And then our next lesson is going to be on applications.